Welcome, everyone. It's a very nice group, and thank you, Stanley, for organizing this and to share and also discuss with each other. The group is not too large, so we will have moments in between. And if you have a question, just drop it in a chat, and then I can pay attention to that, and Stanley also. And then we can maybe, while I'm talking, pause a bit to pick up some question. So I will try to kind of explain the main points, and so that we'll leave some space for the questions. And so I will go relatively fast, and and so if some things went too fast, you can just simply say, "Okay, can you explain more what you meant there and there?" Okay, so that's how we're gonna do it. So the main theme is microservices in relationship to Teams organization. The whole world of microservices nowadays, and the whole hype essentially is really big. Noises, maybe turn off some noises. And it's pretty large, and so there is a lot to say about it from a technical point of view, from all kinds of points of view. And I will predominantly focus on a Teams organization aspect. And without talking about my whole background about this stuff, I'm just going to talk about the relevant part for this talk, which is have been a developer since a pretty long time, and I lived basically through kind of three hypes, and Corba a little bit, and then enterprise Java Beans stuff, and then SOA hype, SOA hype, service-oriented architecture hype. And during that SOA hype, the people start to call you a SOA expert, and simply because you are dealing with a question, and you can and in a day-to-day basis, and but I was not really busy with introducing SOA anywhere. I was mainly busy getting rid of the crap which comes along with it. And so this usually involved getting rid of things like SOAP and EGBs and ESBs, especially Enterprise Service Bus was one of those things. And so trying to convince environment and show them how you can actually do something much simpler, but still holding to the basic principles of SOA, which I'm going to explain a bit more later on. So I spent quite a lot of time simplifying architecture and working with that, and trying to get it to be much simpler. And slowly, at some point, got my interest much more in simplifying organizations and so product development organizations, how to make that simpler. But still today, the two are kind of inseparable from each other, I noticed. And it's this area of a combination of how development organization is set up and how you deal with the architecture seems to be really, really important. And one depends on another quite a lot. And this gets manifested also nowadays, especially in the microservices world. But the problem is that I noticed that quite a lot of companies have thinking too simply about how the advantages of microservices. And there are some really nasty things about it, and to understand and consequences about it. So nowadays I'm mainly busy with simplifying organizations with a less large-scale Scrum as a framework, and quite often I come across microservices and dealing with that. So we'll talk about a bit about definition of what microservices is, not too much. So my assumption is that you do pretty much know what microservices is, and we'll talk about this whole distinction between monolith and microservices, and then dig into the Teams organization and how this relates to it. And I'm going to touch upon two aspects of that. One is the so-called cognitive load, and which is a psychological concept of using your working memory. And that has been nowadays used as an argument often to have teams own a small scope of microservices, and each team has their own part. And the reason for that is that so-called teams cannot possibly deal with a large code base, let's say 1 million lines of code. So we will talk about this misconception basically, and much more in depth. And then the famous Conway's law. I'll explain later for the people who don't know the Conway's law what it is, and also especially explain the misunderstandings about it in a detail. And especially in the microservices setup. And then we're going to dig a bit deeper into the aspects of how to descale the organizational complexity in such a setup, and a bit of dependency management, which is a typical reason why microservices get introduced, that you can somehow keep everything independent from each other. Okay. So first, let's start with the claimed benefits of microservices. So microservice essentially is a piece of software which kind of stands on its own, has a single responsibility, and typically has a database and can provide preferably end-to-end customer feature. So, and those features are kind of separate from each other, and each microservice is supposed to be quite small. Although nowadays this smallness is being debated. So whether it should be small or not small, that's kind of like up to debate. So the actual definition of microservices is, there are different definitions. So it's a bit unclear what we exactly mean by that, but in any case, it's something like that. What's maybe much more important is to look at the claimed benefits of microservices. So the first one is that each microservice can use different technology. And so the teams can independently from each other use whatever they want. And then as long as they agree upon how those services interact with each other. And that sounds pretty good, and quite often it's a good idea, but there is a catch, and we'll talk about that catch. And so based on actual real experience and that you can actually find yourself reports on it and references to it. The second one is replaceability, is that you can replace any microservice independently from other microservices. And so if you want to, which is quite different supposedly in a monolith. So in a monolith, if you want to replace something, then you suddenly need to deal with the whole monolith and stuff, which doesn't need to be true. So in any case, this is the claim benefit. Resilience, so you could ensure that one microservice when one microservice is down, then not the whole landscape is going to be down. So this is one of the benefits of microservices, because if something is down in a monolith, then the whole monolith is basically down. So everything is down. So this is one of the claim benefits of microservices. And then the scaling. So you can scale on a different dimensions if you use microservices, and so you can also scale separately from each other. So if you need a certain type of scaling for one feature, then you can scale, don't need to have a one scaling approach for all the features, if you like in a monolith. So if you use microservices, you could basically scale per microservice or group of microservices, depending on type of scaling that you need. And ease of deployment, so you don't need to deploy the whole monolith for every change. You can deploy each microservice separately and from each other, so which should make the deployment much easier. And then organizational alignment. We're going to talk about that quite a lot. And that's a claim benefit, which is in reality no really benefit, and I'll explain why. It's quite the opposite, in fact. So composability is one of them. Is yeah, I'm going to skip that one. There's not that much about it. Yeah. Okay, so before we get to the microservices, and it's quite important to understand where we come from, and especially important to understand that it isn't really anything new. So we used to have a core bar, and which has a kind of a similar setup where you have these object services, and you can access them over the brokers and so on. And then slowly we shifted to SOA, and so this is typical from the actual document, by the way, SOA architectural description. So you typically have lots of services and then a consumers of the services, and so services can approach each other, and typically you have an enterprise service bus in between, and lots of other stuff which is centralized essentially. This is so there was a lot of centralization of responsibility in the SOA architecture. So that was also the downfall of the SOA, because the more you centralize stuff, the more difficult it becomes to deliver something relatively fast end to end. So if somebody wants a very simple feature which requires access to a few services, then you need to go through this enterprise service bus, and then things start to be quite complicated, especially when it comes to testing, and each of them needs to be separately deployed, and so on and so on. It takes ages to get something done. And especially, and this is really the key thing why I'm telling this slide, is what happens is that in this dynamic of having things separate in such a way, there was a continuous and ever increasing tendency to increase the specialized groups. And so you end up in most organizations having some kind of an integration team, and or an enterprise service bus team, and some kind of or multiple of these centralized groups, which ensure that the connectivity between services kind of happens according to the rules and everything. This made things much worse. It meant that if you would, when you need to implement something quite simple on the front end, and you require change, also a few changes in the services, then you need to go through the like 4 or 5 different teams across the whole organization to get it done. And these are all essentially component teams, but in a really bad kind of component teams, because you're not even talking about the necessary component, but just a huge amount of plumbing which doesn't really do anything specifically, like an enterprise service bus. Okay, so we spent a huge amount of time 15 years ago or 10 years ago, and I was very busy with that, getting this to be simplified. So this mainly meant getting rid of the enterprise service bus, making sure that the responsibilities are at least decentralized, so that the consumer can access the service directly, so that you have less of teams being involved to get something done which actually works end to end. And so this simplification was the main objective. And and nowadays we have a microservices, and which is essentially idea to get rid of lots of this complexity and to decentralize it to the services, and then the services can directly connect with each other, and also to group those services more from a business point of view, and typically by using domain-driven design. And this is also not new at all. We used to do that in SOA world to simplify things. Instead of one big message was always 15 years ago, don't talk about technology stuff so much when you're talking about the SOA, but talk about how the business domains look like, and how you actually group stuff together, so it actually makes sense from a customer point of view and not from a technology point of view. And so that those ideas are just simply kind of picked again in a microservices. So essentially there's nothing really new in the microservices world. And but then what I see nowadays is that we have still a movement which goes back to the problem which we had 15 years ago, with stuff like this API gateway, for example. This is a small sign how things are getting worse again. So the kind of a history repeats itself again. And I'm going to talk about this, why history unfortunately repeats itself again, and we need to be very careful not to end up in the same mess that we already ending up in the same mess with microservices that we know very much from SOA. So essentially, if you want to define one definition of microservices, is basically SOA without technical crap. So you could kind of summarize it like that. That's the intention, at least, which sounds pretty good. And but what we need to be aware of also in discussion about microservices, so there is always a kind of like a two-side thing. Why do we have microservices? Because monoliths are bad. But what exactly is a monolith? Is a monolith that one company has a single application and everything is in that application? Yes, but that almost never exists essentially. Any sizable company has typically many applications in all kinds of ways. So do we call that monolith? I'm not sure. So I think this discussion about the monolith versus microservice is too simplistic. The world is actually much more rich. There is a lot in between. And I'm just going to give a brief overview just to give you an idea that why discussing monolith versus microservices doesn't make much sense. And especially because microservices has a special purpose that's sometimes useful, but usually not, simply because it's on an extreme other end of the scale, basically. So one approach is CQRS, for example. And is that a monolith? I don't think so. Is it a microservice? Also not really. So maybe if you kind of look at it in a specific way, you could say it's a microservice. But then again, microservice is supposed to communicate on top here, but they are communicating like below here. So I don't know. I don't care, to be honest. So, but just to give you a perspective, there is a much more to the architectural world than only microservices. And then this is an overview. Just recently, Grady Butch gave a talk on a Zoom, and so he gave this overview of different architectural styles. And so it's something to be very much aware of, and not to oversimplify the possibilities and of different approaches. And so those different approaches also have a different perspectives. And regarding when you talk about the structure, shared memory, messaging, adaptiveness of stuff, and distributed. So what kind of distribution you have. And you can see here only one is service oriented, and I'm guessing he put the microservices in the same thing. It's not even mentioned here, so it's kind of a funny. Okay, so it's a rather minor approach, if you would say. Yeah. And few lessons from SOA, what we had, which are very, very relevant also in microservices, is that we discovered that the service contract is kind of like should be getting much more attention than typically gets. So microservices discussion and in the companies also on a YouTube, etc., is much more about technology stuff, unfortunately, and much less about how do you actually separate things based on a principle of high cohesion, loose coupling, and and understanding that very, very deeply. And using things like a domain-driven design to help you make a sense out of the mess, and so to avoid the mess. And so the centerpiece of that is a service contract, which essentially describes what is exactly when you separate something. This is the service, and this service, this interface, this capabilities provides to other services, and you can actually make use of that. And we really learned the hard way how incredibly important it is to focus more on that instead of technology. And so focusing on a customer domain and how a customer domain is basically structured. Now, also experience with integration patterns proves to be really valuable, especially when you talk about the teams. Teams generally in that time struggled a lot with knowing integration patterns and when to use which one, and not to end up in all kinds of a messiness, and which proves to be in reality not working. Typical mess in a microservices is that you want to get something very simple, and then it takes like a minute to do a search of the customer data or something like that. And why does it take minutes? Because in order to just execute one search, it needs to go through 5 or 10 microservices. So that obviously is not going to work, because every jump over the microservice is going to delay the response quite a lot. And that kind of explodes a lot with the more jumps that you have. And just to give you a tiny detail of the trouble to get there. And so understanding the integration patterns helps a lot in realizing that some ideas are not a good idea, and know when to apply which one. And now, enterprise service bus, bad idea, just always has been. And iterative development of services is also really important. What does it mean in microservices world is that you shouldn't be starting your development with thinking, let's put up a microservices or something like that. Don't do that. You first put a monolith and design that properly, and then along the way you start to see that some things could be separated and dealt in a separate way from the other part of the system. And that's how you do it. And you do this very, very carefully. And then build upon that further. But you do not start with microservices. That's generally just a bad idea. It's for me even hard to imagine why someone would start development by saying, let's start with microservices first. It's not a good idea. And then additional amount of achievable decoupling. I mean, every context is different. And so we learned in SOA world that if you have a domain which has features and aspects of domain which are not fairly separate from each other, then SOA was actually just a bad idea. And so you better do actually monolith, simply because decoupling was simply not possible, because domain doesn't allow it. Domain requires a high level of integration, so decoupling things is in that context really hard, and it doesn't provide much of a value, because no matter how much you try to decouple, you end up still with lots of dependencies between different parts. And you can say, but that seems to be a failure in how you design and architect stuff. But But it's actually not simply because there is a actual business value in integrating stuff with each other. So decoupling doesn't necessarily provide business value. And it's quite often it's the integration between parts that provides the business value. And so we often compare, let's be like Amazon. Okay, that's a typical example. Amazon has done microservices, one pizza team, and then they deliver their own stuff and independent from other teams. So that sounds really great. So let's depend. Each team delivers their own stuff and don't need to communicate with each other too much. So Jeff Bezos said, so communication between teams is a bad idea. You know, everybody should actually work on their own, and that's it. Much better. Well. The consequence of that is simply a trade-off that Amazon took. For example, at AWS, they did this separation of features, and the consequence of that is a lack of consistency between different parts of AWS in early years. So lots of stuff that you used in AWS was just simply not consistent with each other and was not integrated with each other. That was the consequence. Yeah, and later on, friends, which others also know, I talked to, and what actually happens in Amazon. Well, the two pizza team sounds very cool and stuff, but the reality in Amazon is quite often different. They have the similar problems that we always see, which if you run something which requires high level of integration, it becomes a coordination mess between these pizza teams. Okay, so need to be careful not to assume that Amazon doing stuff is such a marvelous way. Reality can be quite different. Okay, and then versioning. It's really funny. What I notice in talks and talking about the microservices, and that we're now reinventing the stuff that we have learned from SOA time. So one of that stuff is that how to do versioning of microservices. And so then introduce these patterns and stuff, which has been known for 20 years or something, and they can be read in books like very old books like Enterprise Integration Patterns from Gregor Hope. But we learned that the best way to deal with the versioning is avoid versioning. Okay, so and I bet that that it's pretty unknown in this group, and there's so many groups I see that to know how to avoid versioning of stuff. But it's actually quite interesting because it has such a much more benefit to not version at all. But then the question is, how do you do that? Okay. Another thing is that now we're switching to the teams organization. Imagine now, not imagine actually, there is a real war stories on that. That each team owns a bunch of these services. And they work then on their services and a nice bubble, okay, and they can deal with the services, and and they can deliver very fast each of the services, etc. Great, but the reality is that almost all of the issues that are typically in such a situation is not within a single service or a small group of services. The real issues are actually to how do you integrate stuff across the services. That becomes really, really complex. Now, this begs the question, if each team takes care of only their own bubble, who's taking care of the combination of the bubbles? And then you see what happens is that the combination of the bubbles is typically responsibility of somebody outside of the teams, which creates own dynamic. They try to solve the problem without actually being hands-on involved with the experience of the problem. And so you have this start to have in the microservices also world these architecture groups or a separate groups, what we used to have in SOA, which needs to solve these problems. Like how do you do monitoring? How do you do all kinds of things related to transactions, which are very different in the microservices world. You cannot have a transaction across many services. You have to then have these rollback scenarios, etc., etc. So there is and then just simply certain standardization, which is absolutely required, and on usage of the microservices and integration of across many layers. So all these cross-cutting concerns, that's where the trouble is, and that's where the real complexity gets into. Deployment. So you supposedly can deploy one microservice independently from each other, but the reality proves to be much harder than it sounds. In theory, it sounds really simple. In reality, quite often you intend to do that until you figure out that when you deploy a single microservice, it has a side effect on others. And then you end up actually, quite often, many companies end up to still deploying all microservices at the same time. And if your company deploys all microservices at the same time, you basically kill the whole idea that of microservices. So if you do that, so it's kind of a pointless, because that's the one advantage, single biggest advantage of microservices, that you can deploy stuff independently from each other. So this is quite important, and this kind of a lesson that we have. So other alternative is that you have a shared ownership. So if you have many teams which shared ownership of this landscape, whatever the landscape is, then you shift the problem space at least to the teams, which makes it much easier to deal with the problems. The teams start to own the problem of integrating stuff across many microservices at the very least. Yeah. Now, these war stories, which I now mentioned briefly, is that one of them, for example, is typically Uber is mentioned that has microservices. Well, I would definitely, one advice, watch the YouTube clips of the stories of what really happens to microservices. I would skip the blog posts simply because the blog posts tend to give a bit too rosy picture, let's put it that way. And the techie people on YouTube tend to be much more honest what really happens. And so because it's spoken, then they're much more free or something, I'm not sure. So, and they're going to tell you what really happens. And that's much more interesting. You need to then pay attention very carefully what exactly are they saying, okay? And so like Uber, I mean, just to name few known companies, and they have a big trouble and they wish they knew lots of stuff before they started with microservices. And so very independent teams is just not a good idea. And it's hard to share code, hard to move between teams. It fragments the culture that they have, and then they solve things in a separate, all different ways. While it should be solved in the same way, such as, for example, logging. So you really don't want every single service to log in a different way. So you want to standardize on that. And integration gets really complicated because of separation of the teams. And besides it, lots of other component team problems that we typically know from that we talk about also in large-scale Scrum. And you just want to avoid component teams in general. And then you have a Dell, which is truly a disaster, and where architect has envisioned microservices set up, and where they did a one single search. It took 10 minutes to do to find some Dell products, and so it was just simply horrible. It just didn't work at all. And so the Jimmy Bogart came later and he explained this disaster and what they tried to do about it. But then what he explained, what they do about it, they start to break with the basic rules of having microservices. And so they started to do like store procedures and connecting directly to databases to make performance work and all kinds of funny things, which solves the problems which they had at first end, but it creates a long term a really big mess, which goes completely beyond the whole notion of microservices. It's just a mess. And so all I concluded from that talk is that they should have just stayed with the monolith, and it would have been much better basically than what they did at Dell. And and yet another one by Arun Gupta, which is a quite famous person in Silicon Valley. I think it worked in Apple, Google, and all these big companies. And he talked extensively about how to refactor your application microservices. But then he also explained quite a lot what kind of issues comes along with dealing with that. So I would strongly advise to look at this kind of talks and listen carefully what really happens in that world. Essentially, you have in dealing with this complexity, to go back to my previous statement, is you have either shared ownership in the teams, which is pretty difficult to achieve. Okay, that's the honest answer from my own experience, trying and doing this for quite some time now, for quite a few years. There are a few successes where shared ownership in the teams has been achieved, meaning that all teams altogether own all components, all services. Does it mean that everybody touches and changes any service? No, that's not what it means. It just means that they're looking things from the whole point of view. And when they need to change a service, they just change it, regardless who's been working on it before. So you end up in a situation that each microservice or each component, whatever you want to call it, application, is being touched by multiple teams. And that's perfectly okay. ironically enough, over time it increases the quality. And a claim which is often made that if you own a component, the quality gonna improve. In reality, this is only maybe true on a short term, but not long term. And so simply because we start to be biased about our own code. So if you have been working in a certain code base, you know it so damn well that you start to be blind for your own mess. And that becomes only visible when somebody else start to touch or see your code, and then they discover how mess it is, and then you start to defend it, etc., etc., etc. But if you continuously have multiple teams touch upon the code, in the beginning you're going to have a trouble to maintain the quality, but over time it's going to actually improve the quality. In the beginning it's troublesome because people have different ideas what the quality means, and you need to talk about it, and so on and so on. But the alternative, if you don't do that, not shared ownership, is that you're going to have a ever-increasing coordination mess on top of the teams. So somebody needs to make sure that things come together. And we all know this trouble, and big projects which are lots of across so many services and components, we need to make sure that the project is delivered, and etc. Testing takes only after 1 year takes place, and so on. So but the thing is that quite a lot of proponents, they say, but this is actually a false dichotomy, and that you somehow can actually deliver stuff independently from each other as teams, and don't need to actually share ownership, as long as you organize services in so-called bounded contexts, and so that you can actually kind of divide it and decouple stuff from each other a lot. And so much so that you decouple it so well that you don't need to actually don't have actually any significant connectivity with other bounded contexts. Well, then I go back to the actual war stories. This is a very good way to organize your code and organize your services. No doubt about that. But in reality, it's never going to be completely decoupled unless you have some really unusual domain. Okay, where things are really separate from each other. But most products that we're dealing with require quite a lot of integration. And because that's where the value is. And so we need to distinguish between theoretical wishful thinking, which is good to strive, but in reality, you're never going to really achieve it. So you end up still having, in reality, that you need to have a sharing between teams, no matter how much you try not to have a sharing. This becomes very clear in a book from Sam Newman, which talks about stuff like you should use the bounded context to separate, but at the end you're still gonna need to have some sharing, and then he explains all kinds of techniques to still share the code base between teams. But the general idea is that you don't share, but you end up actually still needing to share. So it becomes quite clear that sharing is simply inevitable, and because alternative is a coordination hell, where the teams, nobody cares about actually shared parts, or they only cared about shared parts, not the combination of the parts. So you don't want to have that. Yeah. Okay, let me see. Take a peek at questions. There are quite a lot of questions in the meantime.
Yes.
Yeah. Let me. Is SOA architecture related to MQ message buses? Asking for a non-technical friend. Yes, it's kind of related, because message queue, message buses are very often used element in SOA architecture. It's a short answer. As part of asynchronous communication between services. So one consumer wants to approach another a service, and the way one approach to do that is request and response, or asynchronously, which is just send a message, and then later on message is going to come back or something. Or fire forget. I send a message, I don't expect any answer. A message is going to be processed or something. What is an indicator signal that a team should change from monolith to microservice? I guess you mean change architecture from monolith to microservice. What's the indicator to split things up? Well, indicator is if you notice that part of your monolith that you work with is really completely or almost completely separate from the rest of the application. It clearly solves a different, completely different question. from the rest of the application, and or some really generic question, and then you might consider to separate things from a monolith. Okay. So, so it's basically the level of decoupling that decides whether you should split or not split. And decoupling should be kind of obvious during development. So you first create a monolith and you work on that. And at some point you notice that certain things are really properly decoupled, and the coupling is of a very high level. Then you can consider to take it out and deploy it separately. Okay. So Young, does it answer the question?
Yep, thanks.
Okay, good. So I wanted to have a bit of interaction. What did shared ownership look like? I will show that a little bit later. So when I talk about the feature teams, how it actually looks like. Yeah, avoid versioning. Then what is alternative to manage a version in microservices? We have enhancement to release every 2-week sprint. Yes. I'll explain. One of the common misunderstandings of how you actually create an application with a specific interface or a microservice or whatever you want to call it is that you first need to define interface completely, and then you implement the thing. This is a bad idea. Don't do that. Your interface should be even more iteratively developed than the implementation itself. And so let me take a concrete example. You have an insurance company, and then you have a customer. And so let's assume there is a customer microservice or whatever, and it provides a customer information. So and that customer information is going to be used by many different parts of the organization, of a landscape, other applications, whatever. And so how should the interface look like? Well, you get a first consumer which says, I need first name and last name of the customer, and maybe ID of the customer or something like that. And then what you do is you implement the ID, the first name, and the last name. And that's it. And you put it in production. Okay. And then the next consumer comes and it says, oh, but I need not a first name and last name. I need to have it as a full name, just one field. Okay. Then we add one field, which is full name, on top of the first name and last name. If you do that, you don't need versioning because you just add stuff to it. Okay, so the existing consumer will also receive the full name, but it just disregards. It's not an issue. And so if you start really small with the interface, you're much, much less likely to end up in versioning. Now, in addition to this, so imagine that somebody says, you know what, I don't like this. It's not a good idea to have a first name, last name at all. We should all use the full name, or we should use some even fourth alternative, like a full name, but with the prefix of a I don't know, that somebody is a doctor or whatever, etc., and something after that also, because the regulation came, requirement came that this should be done. So one alternative is to do versioning, to say, okay, in that case we need to have a new version which kills the first name and last name and full name and replaces it with some new field. But if you think about it, it's actually just simply a new service or new information on top of a existing one, because it's based on a requirement that happens at what point in time. And that requirement needs to be fulfilled. It doesn't mean that this requirement is applicable for everybody who actually uses that information. So it's essentially a different requirement, which might even mean a different interface, interface that you have. So you should create an additional interface which has its own name for a specific purpose, and that's okay. So if you have a customer interface, you could have a few different alternatives to how you get customer information based on the need that you have. So one type of consumers that require this information required in a certain way to be presented, and other types required in a different way to be presented. Now let's go a step further. Yeah, but the old way is just not good. That should be actually removed. What you do is then mark those fields and that information as deprecated, or the whole interface definition as deprecated. Don't create a version, just simply make it deprecated. And just like we're doing in a code. And then you simply, over time, then everybody gets known that this deprecated one shouldn't be used anymore. And so over time you kind of decommission it, but don't need to create versions. And so the advantage of a versioning is that you basically, in design of the services, you incorporate how things change over time. But if you use versions, then you basically lose information that some things were applicable and still are, because they were designed at one point in time. And so the time aspect gets preserved. But in versioning, not, because you just see the versions. And the newest version is the important, the old one is just too old. Okay. To answer that question. Okay. So Microservice disaster at Dell. I was there at the beginning. The service registry was slow, hard to... Oh, that's funny. So the person who's here in the group has been at Dell at that time. I was there. The service registry was slow, hard to navigate, took forever just to resolve endpoints. Okay, yeah. I guess you know even more about it, Che. That's funny. Okay. Good. The one other thing is that I'm going to continue a bit and come back to question. Is that if you the consequence of having every team taking care of their own stuff is that you end up needing lots of organizational structured things in order to take care of the combination of things, such as what I just mentioned: system engineer, architects, some kind of a business analyst on top of it, which needs to take care of figuring out how things work over the multiple microservices, and then integration testers, system testers. So organizational structure becomes quite complex if you separate the responsibility across many teams. Okay, you need on top of that additional structure. This is a Conway's law. So the Conway's law, for people who are not familiar with, and for others who are familiar with, what you typically hear about Conway's law is this part: that organizations which design systems are constrained to produce designs which are copies of the communication structure of these organizations. Okay, so this is true. I mean, in the case of a component teams, and the microservices teams, where teams own each of them a bunch of microservices, this is true. So how you organize them will be reflected in what those teams create. And this is because the teams are not flexible in the way they see the whole landscape. They just simply see their own part, and that makes the overall organization quite rigid. And so so if they see their own part, what they need to solve, they will create architecture accordingly. So they will create components which reflect how they are structured. Okay, that's what the left part says. Now the right part is almost never mentioned, actually, and that's also part of the Conway's law, which says to the extent that an organization is not completely flexible in its communication structure, that organization will stamp out an image of itself in every design it produces. Okay, flexibility is the key thing. Because a design that occurs first and is almost never the best possible, the prevailing system concept may need to change. Okay, so you could say, like, let's create the architecture first, and then the wanted architecture we create accordingly the teams. But the problem is that the architecture will change. Okay, so you cannot kind of keep changing the whole organization every time architecture changes. Okay, especially it will actually, simply because of organizational structure, it will actually prevent the needed change in architecture. So therefore, the flexibility of organization is important to effective design. Ways must be found to reward design managers to reward design managers for keeping the organization lean and flexible. Okay. So now the question is, what kind of organizational structure do we need to make sure that we don't stamp out the architecture out of which looks same as the organizational structure. Okay. So I will get to that. And it's the next slide. So that's the feature teams. Okay. So one of the questions was asked but how do you do shared ownership? Well, this is how we do it. So feature team work based on a customer-centric items. So it doesn't mean that they work on a single feature. It just means that they can deliver end-to-end customer-centric feature. That's what the feature teams mean. So each team works basically from the whole product point of view. And when they implement a feature, that feature typically will need reflected in the components that need to be changed. Whether they're microservices or not doesn't really matter that much. So they will change those microservices, and that means that they will quite often change the components which are also being changed by other teams. This means they will need to collaborate with other teams. You cannot just change something without actually discussing with each other certain aspects, especially when it's architecturally significant. So this means that these teams will need to work with each other. And this typically means organizing communities, getting together by pairing across teams, doing multi-team sprint planning tools where you design stuff together, etc., etc. So essentially, you want to actually encourage collaboration, not discourage. But obviously, so coordination between teams is a very good idea. What you do want to pay attention to is the cost of coordination. So you don't want to have some kind of a meeting where everybody comes together, and you don't want to have a special coordinators roles, architects and fake product owners which coordinate with each other and all this kind of stuff. No, you want teams to coordinate with each other directly. This reduces the cost of coordination. Okay, but this is the basic notion how it works in a feature teams. And in this context also, the feature teams are much more likely also to consider that some microservices, for example, should be removed and architecture should be improved, and so on. Okay, it's a very brief overview how this is then to answer the question that we had. Yeah. So what about cognitive load? And of team. I mean, if each of these feature teams need to consider the whole product and need to touch many services potentially, what about the cognitive load? Well, we need to realize the cognitive load relates to amount of information that working memory can hold at one point in time, okay? One point in time. In the case of feature teams, at one point in time, the team will not start changing 100,000 lines of code. They do this over a long period of time because one feature is pretty small and they're going to implement that feature. And they consider the whole, but they're essentially implementing something small, despite that it's actually across 3-4 components. It's rather small. Okay, so over time, a team will learn to take care of more code and can take care of more code. In fact, I experienced myself as a team member, as a developer for quite a long time. I could manage very comfortably 1 million lines of code. It was made in Java. And it was pretty comfortable for me to do that. But the condition to do that is that the code is not crappy, and architecture is not crappy, that you have a proper automation of testing. So this is quite important. Okay, so and teams quite often complain with the fact that they cannot handle so much responsibility. But when we look very carefully, how come they cannot handle so much responsibility? I notice that there is an unclear direction. So people are getting to work on this, and then suddenly something else, and suddenly something else. So the focus is kind of jumping up around without knowing actually why. Interruptions by all kinds of stuff, time pressure to deliver, etc. So these are the reasons why teams quite often complain, I cannot take so much responsibility. Okay, it's not amount of code, unless the code is really crappy. Okay. What about 1 million lines of code of JavaScript? Is that JS? Yeah, I don't see an issue. I mean, JavaScript is a perfectly fine language. So if I can do it in Java, so JavaScript, I don't see much of a difference. So stuff needs to be properly designed, and with the proper design patterns and everything. And so and a really fully automated tested. So if you do that, then yeah, Alex. So you asked the question. Yeah. So I mean, you could say, yeah, but the reality is that the code is crappy. Yeah, in that case, you're right. So if you have a really crappy code, then yeah. But I think you have a much more serious problem than figuring out then that the teams should or should not collaborate with each other. Yeah, that's something to be solved anyway. Okay. 6 minutes left. So the claim, I think I already talked about it. Oh yeah, I want to just take a one more in-depth example. So this is from a Jimmy Bogart talk that I mentioned before about Dell. So one of you actually is even more familiar with this disaster. It's and so he left already, I think. What happened is they wanted to do a search, okay? And so the search, one just search thing, and they search through catalog, pricing, localization, and content. So this information is being combined, and it produces the result when you do a simple search, okay? Search.dell.com. And so this, what happened is that it took like 10 minutes to actually get a result back. And the way they solved that is they basically created a database here, and they pushed all the data, which is here essentially, to the search, and so it can be actually searched locally. And how they pushed it, they basically connect to for example, directly to the database here, and ensure that every time change happens in the database here, the data is kind of pushed to the database here, and it's a database-to-database connection. I'm not sure how they exactly connect to each other, but it's definitely not through microservices interface. So they basically hacked the thing until they had all the data locally here on search.dell.com, where the search obviously becomes much, much faster in a matter of milliseconds because all the data is here locally. And then they simply do ordinary SQL joins, etc., I assume.